Hey friends, my name is C and you're watching the MakesItEasy, and welcome to a new video for A-level fundamentals. And today we are 1.5 for solving cubic and quartic equations for the questions video. And we'll look into the first question, but before we get into it, don't forget to leave a like, subscribe and ring the notification bell so you don't miss on any future videos. And we'll get started with 1.5 for solving cubic and quartic equations. And these questions are from the core pure textbook from exercise 1F, so you can check it out. So here's question 1. So f of z is equal to z cubed minus 6z squared plus 21z minus 26. For part A, show that f of 2 equals 0. So what we do here is that we basically just substitute z by 0 in the equation. So f of 2 will be equal to 2 cubed minus 6 times 2 squared plus 21 times 2 minus 26. And in theory, this should work out to 0. And therefore we can prove that it's equal to 0, like so. Because this right here is equal to 8, and 6 times 4 is 24, and this is 21 times 2 is 42, and minus 26, and if you add and subtract all of those together, you will get 0. So therefore, 2 is a factor. And number 2, or part B, hence solve f of z equals 0 completely. So we know that f of 2 is equal to 0. That means the 2 here is a factor. That means we know that z minus 2 is a factor of the original equation, right? So we can just rewrite f of z as this. F of z is equal to z cubed minus 6z squared plus 21z minus 26. It's equal to z minus 2 times by a quadratic equation, az squared. Az squared plus bz plus c. So now we just have to find what a, b, and c are to solve the equation completely. So for a, it's just quite simple. Because the term a will times by this term here to get z cubed, and there's no coefficient, it's just 1 in the z cubed. Therefore we know that a must be 1. And let's just skip b first and just move on to c first. So we know that c times minus 2, we get minus 26. Therefore, we can just do minus 26 divided by minus 2, and then we'll get you 13. That means c equals 13. So we know that is z squared plus bz plus 13. And now for the b, we can just focus on one term, on which z term, and I'll choose to focus on the z squared. So it will be minus 6z squared. So we're going to make z squared out from the right hand side right here, all possible options. So the first possible option is to do minus 2 times z squared. So let me just write it out here. So minus 6z squared equals to minus 2 times by z squared minus 2z squared. And the second option is z times bz, right? So plus bz squared. So we can just cancel all the z squares out, and therefore we can just solve for b, because we can just plus both sides by 2 as well. That means it will be minus 6 plus 2 is minus 4. Therefore we can rewrite f of z as the original factor, z minus 2, times by the quadratic, which is z squared, minus 4z plus 13. And we can just, if to solve f of z equals 0, that means you can just equate this to 0 and just solve with your calculator or with the quadratic formula for what the equation gets us. So we know that this gets us z equals 2. And for this quadratic here, I'm just going to use my calculator to calculate, but we can use the quadratic formula as well. So we have 1 minus 4, 13. Therefore our answer is z equals, I'll just write it right here. Therefore, the answers are z equals 2 and z equals 2 plus or minus 3i. So 2 plus or minus 3i, and that's the answer. And then we have question 6, or the second question. So given g of z equals z cubed minus 12z squared plus cz plus d equals 0, where c and d are real numbers. Given that 6 and 3 plus I are roots of the equation, write down the other complex root of the equation. So we know that all complex roots come in complex conjugates, right? And we're already given one complex root here. That means the other complex root must be the conjugate of 3 plus I, which is 3 minus I. So 3 minus I, like so. And for part B, write down the value of C and D and the value of D. So we know that we have what g of z is here, right? Oops. We have what g of z is here, and we have all three roots, 6, 3 plus I, and 3 minus I. Therefore, we can just multiply all these roots together, or like make like a cubic equation and just compare it with the original equation. So I'm gonna make a quadratic equation with the two complex roots first. So it will be 3 plus I and 3 minus I. So we know that the equation for the quadratic equation with the complex conjugate roots, it will be in the form z squared minus alpha plus beta z plus alpha beta equals 0. Therefore, let's do it together. So z squared minus alpha plus beta is 6, because it will be 3 minus I plus 3 plus I. The i's cancels out, so it will be just 3 plus 3, which is 6. So it will be z squared minus 6z. And alpha beta will be 3 minus I times 3 plus I. So if just use my calculator, or I can just use the speed trick, where we just basically add the square of the number. So it will be 3 squared plus 1 squared, which is equal to 10. Therefore, it will be z squared minus 6z plus 10 equals 0. So that would be the quadratic equation with the two complex roots. And now we have to just combine this with the root 6. So I'm just going to do it normally by just doing some expansion. So z squared minus 6z plus 10, times by z minus 6 equals 0. I'm just gonna collect some terms by expanding them. So the first term will be z cubed. Second term will be z squared plus times by minus 6z, So it will be minus 6z squared. Third term will be minus 6z times by z, will be another minus 6z squared. Then it will be minus 6z times by minus 6, which is 36z. Then it will be 10 times z, which is 10z. And it will be 10 times minus 6, which is minus 60, equals 0. Therefore, the final cubic equation, will be z cubed minus 12z squared plus 46z minus 60 equals 0. And we can compare this to the original equation here. Therefore, we can see that c is equal to 46. Therefore, c equals 46. And d is equal to minus 60. And these are the answers. And then here's question 9. Find the 4 roots of the equation z to the power 4 minus 16 equals 10. So it's basically like a difference of 2 squares, kind of. So z to the power 4 minus 16 equals 0. We know that this can be simplified into z squared plus 4 and z squared minus 4 equals 0. Therefore, we can just equate some terms. Therefore, we know that z squared plus 4 equals 0 and z squared minus 4 equals 0. Therefore, z squared equals minus 4 and z squared equals 4. So now there are basically 4 solutions. It will be root minus 4 and root 4, and they have plus and minus. Right, so let's just do the easier one. So therefore, z will be plus minus 2, because the root 4 is just 2. And on the left, z squared, the root of minus 4 will be plus minus 2i equals plus minus 2i. And these are the answers. And lastly, here's the question 12. So f of z equals z to the power 4 minus 10z cubed plus 71z squared plus qz plus 442, where q is a real constant. Given that this is z equals 2 minus 3i is a root of the quadratic of the equation, show that for part A, show that z squared minus 6z plus 34 is a factor of f of z. So this requires a bit more step to do. So we know that, let me just write it out. So we know that 2 minus 3i is a root. That means that the conjugate of it, 2 plus 3i, must also be a root. And And therefore, if we were to write the quadratic equation that contains these two roots, as I said just now, the format would be z squared minus alpha plus beta, where alpha and beta are the roots, plus alpha beta. Therefore, it will be z squared minus alpha plus beta, the sum of the roots will be equal to 4. So it will be minus 4z. And alpha times beta is just basically 2 minus 3i times 2 plus 3i. And that will get you, let me just calculate, 2 minus 3i times 2 plus 3i. It will be 13. So it will be z squared blah blah, blah 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 blah, plus 13 equals 0. That means we know that this is a factor. But we have to find this is a factor. And we know that the f of z is a power, like the polynomial of f of z has a degree of 4. That means the highest power is a power of 4. That means you know that a quadratic times a quadratic equals this right here, f of z. That means this must be the other quadratic, and we have to prove this. The way to do this is that we can just write f of z again. So f of z equals to, let me zoom in, equals to z to the power 4 minus 10z cubed plus 71z squared plus qz equals plus 442, and that will equal to z squared minus 4z plus 13 times another unknown quadratic right here, plus bz plus c equals 0, right? So we can solve for a quite easily because a is just 1, because there's nothing here. It's 1, 1. That means a equals 1. And I just skip b first and let's just do c. C will be equal to 13 times c equals 442. That means c will be equal to 442 divided by 13, which is equal to 34. So c equals, so c equals 34. And for b, we can choose what terms to focus on, and I'll focus on the term z cubed. So the way to make z cubes including b will be z squared times by bz, which gets us bz cubed right here, bz cubed. And the second way to get it is by multiplying minus 4z by az, and we know that a equals 1. That means it will just be minus 4 z cubed equals the original equation is 10 minus 10. So it will be minus 10 z cubed. Therefore, cancel, it will be b, zoom out, it will be b minus 4 equals minus 10, and therefore b equals minus 6. So b equals minus 6, right? Let me just rub it out. And we can already notice that we already have the quadratic equation right here. So therefore, it's equal to, I shall just rub this out actually. Therefore, this will be equal to az cubed, az squared is just z squared, plus bz squared, b is minus 6, so it will be minus 6z, plus c is plus 34. And there we go, there we have the answer for this, and that's it. And for part b, find the value of q. So the value of q is basically the coefficient for z, right? For z, just a z. Therefore, we can find ways to get z with this equation right here. So the first way to get z is to multiply minus 4z times by 34. So we minus 4z times by 34. Plus, the other way to make z is to do 13 times by minus 6. So it will be plus 13 times minus 6z. That will equal to qz, right? So just cancel the z. And basically q equals minus 4 times 34, right here. Minus 4 times 34. Plus 13, sorry, this should, yeah, it'll be 13. Plus 13 times by minus 6, right? Therefore, you'll get q equals minus 214. Q equals minus 214. So just to recap how to find q is that we basically just focus on the z, like the terms to make z on the equation. So it will be minus 4z times by 34 plus 13 times by minus 6. And you get q equals minus 214. And lastly, solve the complete equation f of z equals 0. So we have this right here. We have f of z equals this right here. and this right here. So we know from the original equation, we know that 2 minus 3i and 2 plus 3a are already the roots that we're given. So I'm just going to write it down to us z equals 2 plus minus 3i to save some space and to save some time. And we know that this 2 minus 3i and 2 plus 3i is for this equation right here. This equation. That means we have to find the roots to this equation here. And I'm just going to save some time by just typing into my calculator for like what I got. So it will be coefficient of z squared is 1, coefficient of z is minus 6, and the coefficient of like independent of z is equal to 34. Therefore, the z will be equal to 3 plus minus 5i. 3 plus minus 5i. And these are the final answers. And that's it for this questions video for A level fundamentals. For today, we looked into 1.5 for solving cubic and quartic equations. And I hope you'll find it useful and helpful. And if you did, please leave a like and subscribe and ring the notification bell so you don't miss out on any future videos. And if you have any feedback or constructive comments about my channel or my YouTube or my Instagram, you can leave them down below and I'll reply to them. And check out my social media in the description, for example LinkedIn or YouTube or Instagram. And if you need any learning resources or any teaching resources, you can check out my website in the description, or you can type it out in your browser at www.MakesItEasy.com. And I hope you'll find it useful and helpful, and I'll see you all in the next video, which will be a rules and examples question for a new topic, which is topic 2 for core P 1, which is called argon diagrams, which will be super interesting and will be led up from complex numbers. But until then, stay safe and happy learning.